Okay, so it's going to be a slightly different video to what I would normally do. Um, but something's been worrying me now for a few months, really. Well, longer than that, maybe a few years. But yeah, the fact that the Amoc, which is the Atlantic Meridional Overturning Circulation. So basically, this is a global ocean current that is in fact very slow moving. Right at the bottom, it can take tens of thousands of years for a single liter of water to travel all the way around it. But basically it brings warm water to northern Europe specifically, um, and this is fundamentally powered by the difference in salinity. Well, essentially it's like the difference of the temperature of the water, but then different temperatures of water can hold more or less salt. So the colder the water is, the more briny it becomes, and then the warmer water is slightly less briny. But anyway, so um, with us currently dumping trillions of, well, perhaps not trillions, but a lot of fresh water into the oceans, particularly in the northern and southern oceans. But in this case, we're focusing on the northern Atlantic. This is making that cold water that's supposed to be going down to the bottom of the sea and dragging that nice warm water up towards us is actually because it's slowing the system down, making it less efficient. So what's happening is the Northern Europe's actually getting less temperature. Now, this is the kind of thing, this has been like, they've been saying this for a few years, that this obviously is a possibility. This thing will happen this century, when Northern Europe become colder. But it does actually appear that it's happening much faster than initially thought. Not like, day after tomorrow fast, but yeah, it's happening. So here are some of the, so I'm going to focus particularly on the UK in this video. Just obviously I'm from the UK, and the UK is a country that heavily benefits from this. All of Europe benefits from this current, but specifically Scandinavian countries and Britain. And due to the fact that we're an island, we're able, that nice warm water, warms the entire island up. So it keeps our winters very mild, as opposed to a place like Germany, which still benefit from the warmer water and the warmer air as a result, but does get, can get slightly colder than the UK does. So a collapse of the Atlantic Meridional overturning circulation would plunge the UK into profound cooling and widespread drought. Despite the fact that the rest of the planet is getting warmer, Northern Europe would face freezing winter in the extreme, severe disruptions to domestic food production, and dramatically altered weather patterns. One thing that I have thought about is, all the wind turbines that we're building out in the sea. If this happens, in the next few decades, and the sea ice expands, which it could extend as far south as Scotland and eastern England. So basically, where most of the windmills are, specifically along the east coast in the North Sea. I don't think they're designed to have ice fields shifting around them, and so I think that they'll all be destroyed unless there's a way that we can shore them up. Is there? I'm not sure. And then so we'd have an energy crisis, an agricultural crisis, and also the summers would actually possibly be much warmer, ironically, because the air that comes up, the warm water that and the warm air that gets brought up to the UK. I'm not, I'm not a meteorologist, so I can't go into too much sort of detail. But I imagine there's some sort of air coming up as well, and that's warmer. And so it gets up here. What happens? Warm air cools down, can't hold as much water. The water precipitates out rain. But if that warm air isn't coming up to the UK, summers would remain relatively warm, but significantly drier and sunnier, which might sound good in the short term, but it's not going to be great for growing our food. However, it does say a large contrast in temperatures between the northern and southern Europe would likely fuel more violent winter storms. So yeah, so you'd have like that sort of border between where you've got that warm air due to the, I imagine, the Mediterranean, and the sort of cold air of northern Europe. That will be, those two will meet over the UK, which would mean that we'd probably get, a severe mix. Anyway, sorry, I'm waffling. So basically, yeah, so the point of this video is just to sort of express that, people are, normal people like me are starting to see this, and I am genuinely pretty worried about it. But one thing that I like to look at, just, before I knew that it was going to cause the end of the, it's going to be the end of the world, but just as a bit of fun, is this app, Ventusky, which, yeah, so Ventusky, so it's basically just gives you forecast and live conditions for the Earth as far as weather goes. So I do use the premium version, but it is available free at ventusky.com. I just think that they're a little bit more restrictive on how many layers you can have and what information is available and how long the forecasts go. But Ventusky is called that, and this is what I'm using today. So one thing that'd be quite interesting to look at, given our subject, is the sea surface. So you can literally see, right, so basically there's probably a bit more detail to it, but as far as, from my perspective, this is the Amoc. Sort of, you get all this nice warm water in the Gulf of Mexico, and then it flows through this little passage in between Cuba and Florida, and then it goes and gets flung out across the Atlantic and warms all of this area up, all of Northern Europe, all this nice warm water look. And as you get further away, further north, you see that warm water begin to drop off and turn into what it should be. So this is very important to us, and it keeps us nice and warm, because if you look at the same position in the Pacific, because conditions just aren't the same, all of the northern Pacific look, it's all pretty chilly. It's 4 degrees, 5 degrees, 6 degrees, not very warm at all. And as a result, this is Alaska, and this is Russia here. Not many people live here because it's pretty uncomfortable. And with the Pacific look, you can basically see like cold, cooler, warm, warmer, hot, cooler, 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 cold. It's very stratified. Whereas in the Atlantic, yeah, you've got this. So here in Canada, sort of Newfoundland, Nova Scotia kind of area, it is cold. That's what you expect it to be. But because of the way the world turns and the water turns, we end up getting this warmth. That's why I thought what we can do is look at an interesting little thing. So if the sea surface is warming up the land, that must mean that the higher you go, there must be a point where the ocean's not really warming the air up as much. So let's go to a kilometre up. There we go. Ironically, actually, Canada is much warmer, but it's up because it's day over there at this present moment in time. No, it seems to stay. So yeah, so even now, look. So let's imagine that this is actually 2 meters above the ground. We're actually a kilometre up, but just to give us like a rough idea of what today would be like, Wednesday the 26th of the 10th, if we didn't have the Amoc. So in London, it's 6 degrees. Bristol, 5 degrees. Birmingham, 6 degrees. And this is the 6th of June. The 10th of June. Paris today, warmest temperature 7 degrees. So yeah, just highlight there that how important that this system is to us, and it's all, it's already broke basically. All we can do is hope for the best. But I'm going to look into this a bit more and get a bit better at doing this kind of videos, which is a bit off form from what I usually do. But it's very scary. Be afraid. Tell people.